All right, so we're going to go ahead and dive into lesson 9.7. 9.7 is systems of linear and quadratic equations. And I think it'd be great for us to talk briefly about systems of linear equations because we've done an entire unit on systems of linear equations. And if you'll remember, one of the ways in which we found the solution to linear equations was through the process of graphing. And when we were doing that, we realized that two linear equations could potentially have one solution because the two lines might intersect, so this would be one solution. Or the two lines might have no solution because they are parallel, or the two lines might indeed have infinitely many solutions. So now in this lesson, we're going on to the idea of graphing a quadratic at the same time that we're graphing a linear. So a system of a quadratic and a linear. Well, let's just draw a graph of that. So we might have a quadratic function like this with a linear equation going through of it. So it's possible that they might have two solutions because the line might possibly cross the parabola in two spots. It's also possible that we could have a quadratic like this, and we could have a linear function just touching the parabola in one spot. So it's possible that we might end up with one solution. And of course, it's also possible that we might have a quadratic like this and a linear function like this, in which case there's a null set happening. So that's a good kind of visual summary of what might be happening when we have a system of linear and quadratic equations graphed simultaneously. And of course, one of the ways in which we can find the solution to this system is through the process of graphing. So let's just dive right into this first example that I've written down here for you. I'm drawing a coordinate plane. There's my x and y axis. So let's move that one up there. There we go. There's my x-axis. Here's my y-axis. And perhaps the easiest one of these two equations for us to graph is this one right here, because this is just that parent function y equals x. We know that the parent function y equals x crosses through the origin at 0, 0, and has a positive slope of 1. So we can go ahead and just drop that function in just like that. Fantastic. That is the function of y equals x. So the question we have to ask ourselves right now is, how do we graph the quadratic one? Remember, when we're graphing quadratic functions, graphing quadratic functions is often helpful for us to figure out x equals negative b over 2a. What on earth is the axis of symmetry? All right, so we have negative 2 over 2 times 1. That means that x equals negative 1 is the axis of symmetry. And I'll go ahead and drop that in there with a dashed line. Here's the axis of symmetry for the quadratic function. Well, the next question I have is, well, where on earth is the vertex? I know because this is a positive leading coefficient that this quadratic is going to be an upward-facing quadratic. And my question is, where is the vertex? Well, to find the vertex, I have to use the x-coordinate from the axis of symmetry and drop it back into the function. So I have negative 1 squared plus 2 times negative 1 minus 2. 1 minus 2, well, that's negative 1 minus 2, that's negative 3. That means that negative 1, negative 3, 1, 2, 3, there is the vertex of my parabola. The next thing I can easily see from this function is that C is my y-intercept. So my y-intercept is negative 2, and parabolas are symmetrical across the axis of symmetry. So I can reflect that point on the other side of the axis of symmetry, and that's a fairly easy thing for me to do. It would be beneficial for us to find one more point. So I'm wondering now, if I plug in a positive 1 into the function, 1 squared plus 2 times 1 minus 2, I'm really curious to figure out what my y value is. So 1 squared is 1. 1 plus 2, well, that equals 3. And 3 minus 2 equals 1. That means I have an ordered pair of positive 1, 1 coming out of this function. So right here, positive 1, 1 is another point on the quadratic function. And because parabolas are symmetrical, I can go ahead and reflect that and put this point right here. Now I have enough points. 5 points makes me feel pretty comfortable about dropping in the graph of that function. And the question we have to ask ourselves right now, are there any points that the line and the parabola have in common? And the answer is yes. This is a situation where there are two solutions. We have two ordered pairs that represent what these two functions have in common. The solutions are, we have, negative 2, that's this ordered pair right here. And then we have another ordered pair. We have positive 1, that's this ordered pair right here.